Welcome all of you. We are into practice sheet number 20. Today's topic is auxiliary projections. This topic is, you can say, somewhat different compared to all the earlier topics. We have already learned earlier, maybe in your last semester, you must have learned orthographic projections. Now, during the orthographic projections, as you know, the object is kept in first angle, and behind the object there is vertical plane, below the object there is horizontal plane, and then we are projecting the object on the vertical plane, on the horizontal plane, and then we are drawing the front view and the top view and the side view and so on. Now sometimes what happens is the objects have got some surfaces which are not parallel to either HP or VP or the side plane. The object is cut at some angle. Now in that case, we are not in a position to find out the true shape of the inclined surface. Now for finding the true shape of the inclined surface, what we need is to view the object in the direction perpendicular to the inclined surface. So now what we do is, today we are practicing such kind of object. 3 such objects are already shown here. And these objects are such that they have got certain surfaces which are inclined. So now if you see, this is, let us say this is problem number 1. So in this problem number 1, this is the object and this is the top view of the object. So if you can see, the object is seen like this from top. So this is the top surface. As you can very easily note, this edge is here. This is the surface which is behind. So there is a dotted line. And this object you can think of as it is cut like this in the inclined angle. So when you cut like this surface which is shown by this pink color, this inclined surface, if you see from top, the top view of this inclined surface is like this. So even if it is not cut, suppose it is not cut, it is straight like this, still the top view is same. After cutting also the top view is same. Therefore, just by this front view and this top view, we are not in a position to understand the real shape, the true shape of this top surface. That means the inclined surface. Now this inclined surface you can see only if you look in this direction. So if you look in the direction like this, that means perpendicular, this is a direction perpendicular to the surface, inclined surface. So to this inclined surface, if you look in this direction, then it becomes, the view is called as auxiliary view, and the projection is called as auxiliary projection. So now you are looking at this solid. From the front it looks like this, from the top it looks like this, and in this direction it looks like this. So this is auxiliary. This is called as auxiliary view of the object. Now in this auxiliary view, this shape if you see, if you follow the lines shown in pink color, then these lines are showing the shape of this inclined surface. That means this surface which is seen from top is not showing its true shape, but the true shape is this shape which is seen if you look in this perpendicular direction. So you can see the ends, the extreme end. So this is one extreme end which is here. This is the other extreme end which is here. So the line, the object is extended from this line to this line. Now our question is, how do we draw this? So now, in fact, this is the answer. What you see here is the answer. But what is given to you as a data, this is the data. So you are given front view, you are given top view, and you have to draw the projection. Whatever you see in this direction, that you have to draw, which is what I have drawn over here. Now how do we proceed? So let us see how do we proceed here. First thing is, what we do is, we draw lines perpendicular like this. So if you can see these green lines are projector lines. And these lines are drawn perpendicular to this line. They are drawn perpendicular to this line. So you will in fact see that, how is this object drawn? This is a top view. You know how to draw top view. So this top view is drawn by taking the references like this. See, for example, this point 1 and 2. This point 1 and 2 is here. So if you want to show this point 1 and 2, you have drawn this projector line, and then this is your point 1 and 2. Then from 1 to 8 is here. In this case 8 is here, but then in the top view it is shown like this. So this becomes the top view of the object which is already there given to you. Now when you are drawing this auxiliary view, what we do is, first thing is we are drawing these projector lines perpendicular to this surface, and on this perpendicular line somewhere here we start with, let us say, this corner here. So this corner which is point number 1, so this point number 1 we mark here to begin with. Now this figure is already drawn, but when you draw, initially this figure is not there at all. So there is nothing drawn here. Only you have drawn these green lines like this. So all these green lines are there which you have drawn. Especially, first we will concentrate on only the inclined surface. Whose two shape you want to show? This is the shape which is not two shape. So 1, 2, 3, 4, 5, 6, 7, 8, 1. This is the shape of this top surface, inclined surface, that we have to draw here. So we begin with this corner. Now this corner, this point number 1 is here. So on this projector line somewhere here, we have marked point number 1 to start the figure. Now once you mark point number 1, we are now going to draw point number 2. Now the distance from 1 to 2, whatever is this distance is given to you. Now there is another data which I will give you later on. That data is giving you all the dimensions of this part. So how much is this distance 1, 2, distance 1, 8, distance 7, 8. All the dimensions are given so that this front view and top view you can draw. And then based on this front view and top view, you are going to draw this auxiliary view, which I am going to explain to you right now how to draw. So point number 1 is here, which you have marked. Now you want to mark point number 2. Now the distance from 1 to 2, this distance which is there, which is the width of this object. So this object has got a width like this, and that width is not going to change even if you look in this direction. So if you look from top or if you look in this direction, in both these cases, this distance is going to remain the same. Distance 1, 2 is same in the top view also and in this view also. This, in fact, what you see here, this auxiliary view is, you can say it is a kind of a top view which is taken in this inclined direction. So when you look in the inclined direction, this is the top view drawn in the inclined direction. So in the top view, this width is going to remain the same. So the distance 1 to 2 is going to remain the same as distance 1 to 2. So in the data, this distance 1, 2 is given. So same distance you take and go to point number 2. Now from this 2, you are going to point number 3. So you are going to now draw this line 2, 3 from 2 to 3. Now in this case 3 is here. When you see from top, the distance between 2 to 3 is this distance, which is this distance. But when you look in the perpendicular direction, distance from 2 to 3 is this much. So this distance you are now going to show. So what you do is, on this perpendicular line, you can see this 3 is here. So you go to 3 in the front view, then you go to this projector line, and on this projector line, this 3 is going to lie. So you can draw this line 2, 3, which is this line 2, 3, parallel to, in fact I have not drawn, you can imagine that there is one XY line drawn. We normally draw XY line here. So imagine that here there is a XY line. So something similar, there is a line, you can say this line is here. So I'll draw one line here. Imagine that there is one line drawn here. This is x1, y1. So this line here is x1, y1, and the line here is xy. So like from this xy, whatever are the distances from this point 2 and point 3, same way from x1, y1, this is a distance and this is a distance. So whichever way you think of it, if you find it easy to think like that, you can think like that. Otherwise, just go from 2 to 3 along the plane like this. So you got point number 3 here at this place. Now from 3 to 4, where is 4? 3 and 4 both are here. Out of that, 3 we are drawn. Now where is 4? This distance 3 to 4. Now any distance which is perpendicular like this. Okay, this distance is not going to change from this figure. So in this figure, these vertical distances which are there, these distances are going to remain the same. So 1, 2 here is same as 1, 2 here. Similarly, 3, 4 here is same as 3, 4 here. So once you mark 3, you can mark 4 also, according to whatever dimension is given. Now from 4 to 5. 4 to 5, where is 5? 5 is here, 4 is here. So 4, 5, here, this is 4, this is 5. So from 4, you have drawn a line perpendicular here. From 5, you have to draw a line perpendicular like this. And when you draw a line parallel to x1, y1 line, this is your 4, 5. So 4, 5 here, 4, 5 here. This is apparent length, This is the true length of 4, 5. So we have come up to 5. Now 5 to 6, this is not going to change. So 5, 6 and 5, 6 is same along this line. So you got 6. Then from 6 to 7. Now 7 is here. That means it is here. So from 8 to 7, whatever is the distance, 8 we have already drawn. So from 8 to 7, you take, in fact we have not taken 8. So maybe 1 to 8 this distance you have to draw. So this 8 when you take like this, and when you do like this becomes your 1 to 8. Because 8 is here. I have not shown the numbers here. Maybe you can show the numbers here. 1, 2, 8, 7, 4, 3, 5, 6. So the same numbers we are repeating here, and then we are taking them there. While taking there, the distance along this perpendicular is going to remain this same distance, and the distance along the inclined line, that is going to change. So 1/8 here is more, 1/8 here is less, because there is a 2 shape. There is a 2 shape, there is a 2 length. So we have joined all these points 1, 2, 3, 4, 5, 6, 7, 8 and 1. So here it is 1, 2, 3, 4, 5, 6, 7, 8 and 1. So this 2 shape is this 2 shape. So we have drawn the 2 shape over here. Now having drawn the 2 shape, now let us draw the rest of the body. So this rest of the body which is there, we have to draw. So you can start from this 5, 6. This 5, 6 we have already drawn, and this 5, 6 is here. But you can see there is one vertical surface here. This is a vertical surface. So when you look in this direction, 5, 6 you have already drawn. So below 5, 6 there is one more edge here. Same like 5, 6, there is 5, 6 here, and below you can say there is one more 5 dash 6 dash, you can say 5 dash 6 dash. So this 5 dash 6 dash is here. So that you can mark by drawing this line and then lines along the inclined surface. So along the inclined surface you can get here 5 dash and 6 dash, 5 dash 6 dash here, 5 dash 6 dash here. So this is your 5 dash 6 dash, and this surface which is vertical, when you see in this direction, it will be seen like this. So this is not the true shape of this surface. True shape will be, if you look in this direction like a right hand side view. If you take right hand side view, then you can see this surface by its true shape. Right now it is not true shape. So this surface is this surface. Now the next is, let us say this surface, 7, 8 surface. Where is the surface 7, 8 here? Now 7, 8 surface, and below that there is 7 dash 8 dash. So 7, 8 is here, and 7 dash 8 dash is here. Below it is. So you draw a line like it is not drawn, but it is already there. So this imaginary line is a projection line, and this projector line is bringing you 7 dash and 8 dash here. So this surface, this rectangle, which is this rectangle, is going to be your this rectangle 7, 7 dash, 8 dash, 8, 7. So this rectangle is your this rectangle, which is same as this rectangle. Okay. Next comes this back rectangle 3, 4, 3 dash, 4 dash. So 3, 4 is already drawn there. Now below 3 there is 3 dash, below 4 there is 4 dash. So where is 3, 4 and 3, 4, 3 dash, 4 dash? 3 dash, 4 dash is here. So you take them over here, and now when you draw a line like this, then this is your 3 dash, this is your 4 dash. So 3, 3 dash, 4 dash, 4, 3. 3, 3 dash, 4 dash, 4, 3. 3, 3 dash, 3, 3 dash, 4 dash, 4 and 3. So this dotted surface which is behind is this surface. Okay. And lastly, this edge. There is one edge here. This edge, when you look in this direction like this edge is hidden. So when you project like this becomes your hidden line corresponding to this edge. So this back surface which is there, where is this back surface? This back surface is this back surface. This entire surface is back surface. Okay. So like that, we have shown this particular object in the auxiliary direction, like this. Now let us go to problem number 2. Now this is problem number 2. This is the top view that is given. This is the front view that is given, and all the dimensions are given to you. So that this and this figure, front view, top view, you can draw. Now in this object also, if you see, front view is here, top view is here, and this is the inclined surface. Now this inclined surface shown by this pink line, when you see the top view, that means when you see from top, the object looks like this. This pink line, that means the surface here, this surface is this surface 1, 2, 3, 4, 5, 6, 7, 8, 1. Now this is the top view of this surface, but this is not the true shape. This shape is not true shape because you are not looking in the direction perpendicular to the surface. Therefore, this is not the true shape. So how do you get the true shape? For getting the true shape, you have to look in the direction perpendicular to the surface, like this. So when you look in this direction, you are going to see the true shape of this object. So in the same way like what we have done for this problem number 1, same way we are now going to look at this problem and try to draw the auxiliary view by looking in this direction. So first thing is, this is the inclined surface and we are going to draw the true shape of this inclined surface that we are going to draw first. So we draw all the lines perpendicular to the surface. All these green lines are drawn. They are drawn perpendicular to this pink line. Now on this particular line, see this point number 1 is here. That means in the front view, point number 1 is here. So we are starting with point number 1. So on this projector line, somewhere here at random somewhere, we are going to mark this corner, and this corner is point number 1. So this point number 1 is same as this point number 1. So we have marked point number 1. Now we are going to mark point number 2. Now this distance 1, 2 in the top view is going to remain the same even in the inclined direction. So this distance from 1 to 2 is not going to change. Therefore distance 1, 2 is taken on the same line and we got point number 2. Now point number 3 here. Now this point number 3 in the top view here and point number 3 is in the front view here. So draw this projector line like this. This projector line is going to show you point number 3, and if you draw a line from 2 parallel to the inclined plane, then this line is going to show you where is point 3. So 3 here, and 3 here. Now 3 to 4 is not going to change. So whatever is 3, 4 here, that you take along the projector line and get point number 4. So you got point 1, point 2, point 3, point 4. Now from 4 to 5 you have to go. Where is point 5? Point 5 is here. That means point 5 is here. So you project like this. And however, where are you going to take point number 5? On this line, from point number 4 you draw this line. So once you have to draw a line along the inclined plane, and once you have to draw the line perpendicular to the inclined plane. So this line is parallel to inclined plane, and on this parallel line where this line is intersecting, that is going to give you point number 5. Because you know the same shape you are going to draw here, only this is the stretching. This line is stretching. This along this line, whatever is there, that is stretch. Say for example 1, 8 is short here, 1, 8 is long here. 2 to 3 is short here, 2 to 3 is true shape. So like that 4, 5 is true shape, 5, 6. Now where is 6? 6 is same along with 5. So at this point is 5 and 6 both. So when you draw this line 5 to 6, you take this same 5 to 6 and get point number 6. Then from 6 to 7 along the inclined surface. So from 6, draw this line like this. This line is drawn along the inclined line. And from 7 to 8, or from 1 to 8, this is 1 to 8, this is 8. So you project like this and draw a line from here. That is going to be your point 8. Now 8 to 7 is true shape, true length. 8 to 7 is true length. So take 8 to 7 true length, and then 7 to 6 you can join. That's 7 to 6 with this. So like this, you can draw the entire figure for the inclined surface 1, 2, 3, 4, 5, 6, 7, 8, 1. So we have drawn this surface, which is inclined surface. Now for drawing the rest of the object. How to draw rest of the object? Let us look at this surface first. This is the surface below 5, 6. So this surface is here. So for drawing this surface, imagine 5, 6 is here. Like that there is 5 dash, 6 dash below. Exactly below 5 there is 5 dash, exactly below 6 there is 6 dash. So 5 6 5 dash 6 dash. Now where is 5 dash 6 dash? 5 dash 6 dash is here. So when you draw a line like this, which is not drawn here, but if you draw same way, green line, then on this green line, when you draw perpendicular from 5 and 5 6, this is your 5 dash, this is your 6 dash, and this is the surface 5 dash 6 dash 6. So this surface is this surface, which is same as this surface. So we have drawn this surface. Now let us draw surface 7 8. Now 7 8 is here. 7 8 is here. Now below 7 8, exactly below there is 7 dash 8 dash. So this surface is 7 7 dash 8 dash 8. 7 7 dash 8 dash 8. Now this is 7. Now where is 7 dash? 7 dash is here. So when you project, this is your 7 dash. Similarly, there is 8 dash here. So on this line and on this line, here is 8 dash. So you have got 7 7 dash 8 dash 8 7. So this is the surface, which is this surface. Same thing behind, there is 3 4 3 dash 4 dash. So 3 4 is already there. So you can same way you can draw this 3 dash 4 dash, so that this becomes your back surface, which is here. Okay, so we have drawn this much now. Where is now this back surface? There is one surface here, which is this 2 1 2 dash 1 dash. So this is 2 1. Where is 2 dash 1 dash? 2 dash 1 dash is here. So when you project like this, then this is 1 dash and this is 2 dash. So 1 2 2 dash 1 dash and 1 is same as 1 1 dash 2 dash 2. So this back surface is from here to here. Okay. Now there are two more edges here. One edge is here, other edge is here. So, and this is full width. This is up to full width. So edge at this point is here. Edge at this point is here. So therefore there are two more dotted lines for these two edges and one more dotted line for this edge, because these three edges are not seen when you look in this direction. So that becomes your auxiliary projection for the second problem. Now let's go to problem number 3. Now first try to imagine how this object is. Again same thing, this is the front view and this is the top view. Now this is the object. This object looks like this. In fact this line should be dotted line. This line is behind, so dotted line. You can see the shape